All right, everybody, this is 12.3. Today we're talking about radians. We talked about radians a little bit when we were in our trig unit, because when you use your calculator, when you use like sine or cosine or tangent, we had to make sure that our calculators were in degree mode. Okay? Because some of you guys, when you got your answers, they were not the same. It's because they were in radian mode. All right, so radians and degrees are both units of measuring, for measuring angles. Okay, so today we're going to talk about where radians come from, and hopefully by the time we're done, you'll be able to explain in words or by doing a sketch like we do in our homework. I think that's our first problem in our homework, is to explain what a radian is, or what is 1 radian. Okay, I mean, circles, we know they are 360 degrees, but what is a radian? All right, so here is an activity that we did in class. We used pipe cleaners. Okay, so we basically measured the length of a pipe, or of a radian. So we cut a pipe cleaner so that it would be the same length as the radian. So we would measure that with a pipe cleaner. And then the second step is to draw a radius and then use that pipe cleaner to kind of follow along the edge of a circumference. Okay, so if the radius is like here's maybe like inch and a half, then we would also take that inch and a half and would curve it around. I guess that won't really work. Let me try a different pencil. Would curve that same radius and we would wrap it around the curve of that circle. Okay, and so it would be something like this, and it would stop. So this would be 1 radius. Oops, missed that I. This would also be 1 radius. And then I asked you to put a point there and then connect those together back to the center. And then we would do that again and again. Okay? And I think maybe a better way to kind of explain this, and I'm not sure if this will show up very well, but we'll see how this goes. Okay, where was it? Circles, and then radians. Okay, so this is basically what we did. Okay, we have a radius that can give us a whole circle. So there's our radius. We can take that radius and turn it and follow the edge of that circle. Okay, so that's still a radius, it's just on the side. And the angle made by 1 radius is 1 radian. Okay, so we could do that 3 times. That'd be 3 radian plus a little bit. That's like 3.14. That's pi. And then if we were to do the other half, that would give us 2 pi. So that's basically what we did for our activity. But again, what's probably the most important is that the radius curved around the circle makes an angle. Okay, so the edges of both of those sides of this red circle makes an angle, and that angle is 1 radius. Okay, so that is basically what we talked about. So let's see, hope this worked out. All right, so that would give us, or maybe I'll use a different color, use blue. So this angle made by 1 radius gives us what's called a radian. Okay, so they're very related. You just take that radius and you curve it around that circle. It makes an angle, a central angle, and that angle is what's called is 1 radian. Okay, so make sure you are able to talk about that on your homework. I asked you to do something about that. And then again, kind of like the picture showed, is that we could continue this process. I'm just kind of guessing here because I'm not actually measuring it very well. So that would be 3, and then if you did this a little further, that's like the 0.14. So this is a semicircle would be pi radians, and then we could double that to give us 2 pi radians. Okay, so I think in the classes we kind of did this some more. So that'd be 4, and then there'd be 5, and then there'd be 6. So that'd be 6 whole pi pieces, and then we'd have this part would be like 0.28. So you get 6.28. So that's what we had here. All right. And then we talked about how what we basically found here is 2 pi. 2 pi is 6.28. Okay. And then we already talked about like what is 1 radian. So we kind of talked about that already. And then number 6 is that we're just basically saying that the radian, like a full rotation in radians would be 2 pi, and the full rotation for degrees would be 360 degrees. Okay? And then we're going to write our ratio so that we can switch between radians or degrees. So that'd be like for 2 pi, it would be 360 degrees. Or we can simplify that as pi radians over 180 degrees. Okay, so this is kind of what we're looking for. All right, so I know this probably doesn't go super well since we're not actually doing the activity together. But again, I think go back to that little like video in this video and make sure that you kind of understand where that's coming from. Okay, how we come up with 1 radian, and it's related to the radius. That's the name. It's a very similar name. Okay. All right. So being able to switch back and forth. So let's kind of go back to maybe something that you are familiar with. If you had something like 10 feet, how would we write that in? How would we switch that into inches? Okay. How do we convert it into inches? Okay. And the way we can do that is, well, we know that 12 inches is in 1 foot. Okay. So this is like 12 inches is the exact same as 1 foot. So if you kind of think of it as like a ratio, they're like the same. We're not really changing it. If you had the 2 lengths side by side, they're exactly the same. So that's what we do when we convert, is we could cancel out the feet, maybe I should just the feet part, and all we have is inches. So we'd get 120 inches. So 10 feet is 120 inches. I think that kind of makes sense. Okay, so we're doing the same sort of thing. If our unit is in degrees, okay, then if we want to switch it into, or sorry, that says radians, switch from radians to degrees. So if we're in radians, some sort of number that would be in there, then we would need to basically multiply it by a conversion factor, where we have like, maybe we want it to be degrees, so degrees is on top, and in the bottom we would have it in maybe radians. So that way our radians could cancel off. Okay, so, or if we wanted to switch it from degrees to radians, then we'd want radians on top and degrees on bottom, so that the degrees top and bottom could cancel. So anyways, those are kind of like how we convert. Let's do a couple of those together. So let's look at maybe 8a. Okay, so it's 225 degrees. So we're going to multiply it by pi over 180 degrees. Again, the degrees on top and degrees on bottom would cancel. And then we just need to simplify our expression. All right, so in your answers, I don't want you to plug this all in, because if you do, you'll get a decimal that never ends, and you'll have to round. And we want everything to be exact. Okay, I want your exact answer. So in our answer, we're still going to have pi when we're done. We just need to simplify this part. So it's 225, and then it's dividing by 180. Okay, I mean, if you wanted to, you could do 225 pi over 180, and maybe that's a good way to do it. But then we just want to simplify the fraction, like the integer numbers, whole numbers. So keep pi on itself. We'll do 225. So if you have a Casio, this will probably simplify it for you. If you have a TI, then you probably need to do math frac. And if you have questions on that, there's just a button on your calculator right underneath, like the green alpha button. There's a math button. You'll push that. Because like when you plug this in, we get 1.25. And we don't want 1.25 pi. Okay? We want to change that to be a fraction. So we'll do math, and we'll choose frac, and you'll push enter, and we'll get 5 over 4, and we still have that pi, so 5 pi over 4. Okay, so let's try another one. Again, we'll multiply it by the radians, so pi radians over 180 degrees. So again, we're going to have the pi. We just need to come up with the fraction, simplify the fraction. So 315 divided by 180. So here I get 1.75, but I want to change it to be a fraction, so that would be 7/4. And then just for the heck of it, we'll do this one too. So we'll multiply it by pi over, that's pi radians over 180 degrees. Okay, so you could write rads, R-A-D, or write it all the way out if you wanted to. But typically we don't write a unit for radians. Radians, again, it's like a, it's pretty, if I remember correctly, it's unitless. Okay, so we don't typically write like rads with it. Okay. All right. So we do that. So 210 divided by 180, and I would get a decimal, so 1.16 repeated. We'd write it as a fraction. So I end up getting 7/6, so 7 pi over 6. Okay. So again, if it helps, you could write these together. Remember, you multiply straight across, and then you could just simplify that if that helps. All right, so that is going from degrees to radians. Now I'm going to go the opposite direction. So this is radians. So if we have radians and we want to cancel it out, we'd have to have radians on the bottom. So here we're going to have pi radians on the bottom and 180 degrees on top. So one thing, what do you notice about their pi's? We have a pi on top, a pi on bottom, so those are all gone. And now we just need to evaluate, so basically we have 3 over 4 times 180. So you can type that into your calculator if you want. You could do 3 times 180 and then divide it by 4, or you can do 3 divided by 4 and then times it by 180. Either way, you should get 135 degrees. So your answers here should be whole numbers. Make sure you use the degree symbol. And again, everything above, everything should have pi in your answer. Okay? All right, so let's try another one. So we'd multiply it by 180 divided by pi. Pi's cancel. So we'd do 7 times 180, and we can divide it by 6. So I get 210 degrees. And then the last one, so 180 degrees is the same as pi. Pi's cancel. And we get 5 times 180 divided by 3. So here I got 300 degrees. Alright, so that's basically it. If you have any questions, please let me know. If there was anything that was not clear, again, I do my best on the videos, but sometimes I kind of miss something, or maybe it's not as clear, and there's no questions, obviously, that people can clarify. So make sure you come and talk to me if you need to, okay? I will see you later.